We're going to be looking at recursion. To be able to explain this concept, I'm going to build a class and then I'm going to explain the code for that class. I'm going to start by naming my class recursive class. You can name it anything that you'd like. It doesn't have to be called something recursive, but in this case is more descriptive. And within this class, I'm going to have this static public int method called findNumber that is going to look at an array of numbers and try to find a number within it. So imagine that we had an array of number 5, 6, 7, 8, and I say find the number 6, then it's going to give me back at which index the number 6 is at. I'm going to call that method, I'm going to give that method a few arguments. The first argument is going to be the array of numbers that I'm going to be looking through. The second argument is going to be called start index. In this case, where do I want to start? Do I want to start at the beginning or in some other spot? And then the last argument is going to be the number that I'm looking for. So in this case, these three parameters will help me look through this array. Now, this could be easily done with a loop. So you just loop through, you check each number and see what it's looking for, and once you find it, you return that number. But since I'm trying to show sort of a simple example that's easily understood, I will create this algorithm recursively instead of with a loop. Now, the first thing that I'm going to need to be able to do something recursively is have a termination condition. So a termination condition is when do I want to stop calling the same method over and over again? When do I know that I'm finally found what I'm looking for? And then you will also have a recursive call, which is call this method again if you haven't found what you're looking for and give it the correct parameters or arguments that it needs. So the first termination condition is I'm going to look at each index inside of this number array, and I'm going to check if it's the number that I'm looking for. So if num array start index equals num, then return start index. Now start index in this case it serves a good purpose on the first time that I call this method, but then it starts getting a bit confusing. So we're going to change that name soon. But first, I'm going to make my recursive call. I will have something like int result, and then I'm going to say result equals whatever find number gives me. So I'm calling find number inside of find number. And this is what recursion is. You call something from within itself and eventually it'll stop because you have a termination condition. What are the parameters that find number needs? Well, it needs a number array. So I'm going to keep that number array the same. Then I'm going to give it an index to start with. But the next iteration shouldn't start in the same spot. The next iteration should start at one higher. So I'm just going to increase that, and then I'm going to say still look for the same number. Don't look for something different. In this case, start index starts sort of being a bit confusing. So instead, I'm going to call it cur index. And this will say, well, the index that I'm looking at right now is this. However, this cur index plus 1 call is not quite as clear as I would like. So instead, I'm going to do this outside. I'm going to say int next index will be current index plus 1. And instead of doing the calculation inside this parameter, I will do it outside. And now my call is a bit more clear. So the result is going to be whatever this function returns. If I don't find my termination completion, then I'm going to continue to do this until I'm done. But you're going to notice that this method is supposed to return an int, and right now it doesn't return anything, or at least it only returns an int when it finds the termination completion. It should always return something. So in this case, it's going to return the result eventually, once it's all done. So now that I have my small algorithm, I'm going to look at my tests, and I'm going to run my first test. In my first test, I'm going to look for the number 7. So I'm looking for the number 7 inside this array of numbers, and I'm going to want to start it at 0. So as I start at 0, look through each one, and then find the number 7. If you find the number 7, give me back the index of that number, and then I will check it. The index of 7 within that array is 2. 0, 1, 2. So the answer should be 2. I'm going to check the result against the answer, and I'm going to make sure that it's true. So result equals answer, and that should be able to pass my test. So my initial algorithm works. Now let's look at another test. What happens if the number is not in the list? So I'm going to look for 10 in this numbers array, but there is no 10 in here. So hopefully my recursion is still okay, but it's not. So I'm going to go in here and check and see what the error is. In this case, it gives me an index out of bounds exception. So what's happening most likely is that I'm increasing index and it becomes 1, and then the condition is not met, and then becomes 2 and 3 and 4 and 5. It eventually becomes too large. So instead of being index 5, it becomes index 6, and then when it's index 6, it tries to look for the number at index 6, and that's index out of bounds. I can't do that. So I'm going to create another termination condition. And in this case, this termination condition is going to say, if you look through everything and you didn't find it, then just return some error number that I'm expecting. In this case, I'm going to make that error number a -1. So I'm going to say if the current index is greater than the length of this array, return this number that I am considering to be an error. Obviously, an index of -1 shouldn't exist, so if I ever see a -1 in this, I know there's something wrong has happened. So hopefully this works. I run it, and it doesn't, and I'm still getting an index out of bounds, even though I've done what I think is correct. So what's going to happen here? Well, at some point, this is going to turn into 6 as recursion happens, and I'm going to still check for num array 6. And then I'm going to check if it's too big. Well, that doesn't make any sense. I should check if it's too big first. And if it's not too big, only then should I go ahead and look for that. Let's run this again. And in this case, it's still not working. Now what's happening is that the length is 1 too big. So what's going to happen is that this length is going to return 5. In this case, there's, 5. 1, 2, 3, 4, 5 elements. But the largest index is 4. So 0, 1, 2, 3, 4. So I'm still looking 1 too far. I go ahead and subtract 1 from it. I run my test. Oh, sorry. I run, yes, my find a number. That one's fine. My not in list. And that one's fine as well. So I've been able to pass my test. Now I'm going to look at an empty list. And I'm going to say start at 0, look for 10, but for some reason I gave you nothing. You should be able to handle that as well. So what's going to happen is that current index starts at 0. Num array length is 0. In this case, it's going to subtract 1 from 0, so it's going to be -1. So the initial one's going to be 0 is greater than -1, so it's just going to return -1. So that should work. and then I'm going to look for a number that appears twice, and the first one should appear. So 0 should be returned. And my base case in this case is just going to return immediately. This is going to come in here. It's going to return right away, and it's never going to happen. A recursive call is never going to happen. So all my tests are passing. Now, let's look at how recursion works in general. So we have this recursive class. Now, this recursive class has some tests for it. So at the top, I have my recursive class, and then at the bottom, you'll see the tests. And in this case, I created some numbers, and then I'm calling this function. Then I have this array called numbers, and this array called numbers just has 4, 5, 7, 11, and 8 inside of it. And then I create this call to this function. And what's going to happen when I create a call to a function is that I'm going to allocate some space for this function. And when I allocate space for this function, it's going to create some local variables. Those local variables are the arguments, the parameters. So num_r is a local variable, cur index is a local variable, num is a local variable. So this call to this function has all its local variables as of now. Once I create those local variables, I'm going to check for the termination completions, and I'm going to go through the logic. And when I am done, I'm going to return a number. This number is going to be stored in this int result variable. So if the termination completion happened right away, like the last test, this function would just return very quickly. But in this case, I'm looking for 7, and 7 does exist in there, and my termination condition doesn't happen. Because first, the current index is 0, then number array length minus 1 is 4, so 0 is not greater than 4, so it's not going to return -1. We're going to look at current index 0 in num array, which is 4. 4 does not equal 7, so it's not going to return that. So then it's going to go to my logic next. And what's going to happen is that I'm going to increase the next index by 1. And here I've done something a bit different from my code. What I've done is that I'm just going to return whatever fine number it gives me. I'm not going to store it in some variable and then return that variable like I did before. I'm just going to return that right away. But I'm creating another call to this function, to this method. And whenever you create a call to a method, it's going to allocate some space to it, and it's going to create some local variables again. And it's going to wait until this method returns something. So we're now in the light blue arrow, we are waiting for the dark blue method to return something. Interestingly enough, if this was a different method, like a sub method, then it would sort of be easier to understand because that method is going to return something and will return the value. But in this case, it's another instance of the same method. So it seems like the method is doing it to itself, but it's really just creating another instance of itself, and it's going to call it from within itself. So you could think of it as like objects creating other objects of themselves. In this case, the method is an object, and it's got a space in memory. So we're going to create some local variables for that instance of this method. And then in this case, current index is 1, it's not 0 anymore, and we're still looking for the number 7. We do the same logic. We're going to look at current index is 1, it's not greater than 4. We're going to look at the next spot in num array, which is 5. 5 is not equal to 7, so we're not going to return anything. We're going to create the next index one more time, and then we're going to create one more call, one more instance of this method. And our blue is still waiting. Our dark blue is now going to be waiting because another instance is going to be created, and then that instance needs its own local variables. Same local variables, different values. I'm going to check if current index, which is now 2, is greater than 5 minus 1, which is not. and then I'm going to look at the next index. So now I'm looking at index number 2. Index number 2, as you look into the green arrow, is now 7. So it's going to say, is 7 equals to the number I'm looking for? And the number I'm looking for is 7. So yes, it is. We're finally going to return something. And what we're going to return is whatever current index's value is right now. So current index's value is going to be returned. Now, as you can see, the blue arrow is going to return to. So that instance is going to tell what it was being waited on. So the light blue arrow was waiting on the dark blue arrow to return something, and the dark blue arrow was waiting on the orange arrow to return something. And in this case, it sort of bubbles back up. It keeps on returning that same value because the other calls that it made are returning that same value, and so on. So we're finally at the light blue arrow. The light blue arrow was the first call that we made, and that first call that we made said that we were going to store that value inside of result. So we're finally saving the result that we're looking for. We have recursively looked through this array to find the index of some number that we wanted to look for. In our test, we're going to see that the result is 2. We're expecting the answer to be 2. We assert that it's true. In fact, it is. And we are all done recursing through.